In this video, we will discuss about how can we simulate spray painting using Ansys Fluent. So maybe I'll take a spherical or a half hemisphere kind of structure and I'll try to paint using a spray injection. So we'll just create a design. So I'll be selecting a sphere 50 mm. And then I'll try to create another sphere with 48 mm, and then I'll just go here, structure, and I'll subtract the internal sphere. Now I'll try to delete this, Now this is an empty sphere. If you can see, with the thickness of 2 mm. You can see, right? So this is an empty sphere with thickness of 2 mm. You can just see. Okay. So now we'll try to create a air volume outside and outside the we'll just cut the sphere first point, then these all planes are not required. Delete these two. I will split the body with respect to this plane and remove this. Okay. Now this is a hemisphere onto which I need to coat, and I'll just move this plane maybe to 6. So now onto this plane I'll create a rectangle this should be sufficient. Then I'll extrude this by pulling no merge. Maybe I'll create a symmetry option or okay 80. And after that I'll just go to design, combine, select this and remove this hemisphere. So I'll delete this. I can delete this also. Now this is a domain, if you can just check, which has a hemisphere kind of structure onto which I just want to spray the paint. You can just check. Transparent, I'll try to hide this face. There is a onto this face. Now I'll try to inject the spray. Now we need to select a point from which we want to inject the spray. Maybe I'll just try to identify. Right. So if this is the origin, and from this point to this line the distance is 63.6533. so maybe then we will start our injection from point 20. So I'll just note it here in the paint so that it will have a reference for us. So we'll just note the x-axis, y-axis and z-axis. X will be 0, sorry, X is 0 mm, Y is minus, we'll take 30 mm, and Z, it is also 0 on that plane. Okay, Z is also 0. And along the X direction, we can have a motion to the spray gun. So the gun can move along the X direction, right? So that velocity with which what it is moving, we'll just identify in the coming setup. So I'll just minimize this or just close this. Time being, it's not required anymore. Maybe we need to identify that the sphere surface, right? So we'll create a wall for that hemisphere. So we'll just hide this face and select this face, go to groups, create group. This is a wall spray onto which we need to spray our paint. Okay, now close this, go to workbench and double click mesh. So as it is a student version, we have a limitation and we can use only 4 cores. Start the meshing process. So meanwhile, we can have an assumption with which the spray will move. Maybe we can take velocity of 5 mm per second. So if it moves at a velocity of 5 mm per second, it is like dx by dt. This is the rate of change of position of the spray in the x direction, that is 5 mm per second. Okay, now so x should be a function of time, so it is like dt, and so if you try to have a definite integrals, so it is maybe any some time, we will take 1 second, so then it will be 5 1 minus 0, so it is like 5 mm, right? But we don't know the time through which it travels, so we can just assume like 5 into t, till what time it will travel. Initially the time is 0, right? So you can take 5 into t. So this is the x location. So now x is equals to 5 into time. Time is the current time. So we can get 5 into current time. Current time is the macro which indicates the time of the simulation. Okay. So we will try to mesh here. So I'll take a simple mesh. As it is only a demonstration purpose, I will not go for any complicated mesh. Try to import the geometry. After that, I don't add any local sizing. I'll just click update, generate mesh. I'll go to curvature and maybe keep this as 1 is sufficient, and I'll make the curvature angle as 30. So it has only fluid region, no solid region. Yes, share the topology. Need not share the topology because it is only one single object. So that the warning will come. Need not share topology because there is only one single object. So you can see the model has only one object. Yes, it is wall. We don't have any solid, so it is dead. One second. update region. We'll just verify whether we got correctly or not. Mark as updated. Generate volume mesh. Generate volume mesh. So yes, here it is the issue. We'll go to update region and revert edit. So this is dead and this is fluid. Update. Mark as updated. Generate volume mesh. Will take some time for the mesh. So the wall spray is nothing but the internal part of the hemisphere. Anyways, we don't want that because we are trying to only model the walls, not the solid regions for the spray painting. So we have got a count of 0.3 million, which is okay for us. You can see this is an empty one. But we need to be a bit careful in checking the spray. Okay, the spray here, if you can see, yeah, it's correct. Now we'll switch to solution. Yes. So now the Fluent is loading. So we need, it is a transient simulation because it will change with respect to time. So first we need to activate the transient option. Along with we need to do the gravity direction also. Check the domain sizes too. This is the domain. So I'll try to scale it up. It's in mm. So maybe we'll try to scale it by maybe through 10 units, so that it will be much more apt for the simulation. So we need to give the boundary, gravity direction. Try to activate only the hemisphere. Check the gravity direction. So we can give in x direction. Okay, so x as minus 9.81. So that is a gravity. And then you can go to models and turn on the energy. It's not required, but yeah. So we'll turn the discrete phase on. Interaction with continuous phases in the physical models. So we'll have a stochastic collision as well as breakup. So the particles can break or it can collide to each other also. So it can form a collapse or a new particle altogether. So but there is no collisions. So it is a stochastic collision. It does mean that when it is within the range, it will take a probability whether the particle will collide or not. And the probability, if it is greater than the threshold value, automatically the particle starts forming a new particle even though they are not collided. Okay, it is based on a probability. To create an injection, so we will try to have a cone injection. So cone, and so we will have the positions and variable positions. We will just vary that. Every time is 10 seconds I'm taking. So direction is like y is equals to 1. You can see here. So y in the one direction and velocity maybe about 12 meters per second. Cone angle maybe 4 degrees and this 0.01. Update injection display. So it is okay now. Click OK. And I'll just change the number of streams also. This 20 streams I'll select. Okay, close. Then in materials I'll try to assign water as my injection. Of course you can select any paint also. If you have the properties of paint, you can just go and select the paint, but right now I'm selecting water as my injection. Close, and now I'll go to injections and I'll change the material as water liquid. Okay, and maybe I'll try to, okay, so I'll leave this as it is. Now on to the wall, go to solid wall, and in the DPM you can activate a wall film. So when it strikes the surface, it will try to fall. It will try to create a wall film, and you can just go to UDF. You can see. So this is the UDF where the position is. It is at 30 mm. So we can increase this definition. So it is at 0.03 and 0.005 the current time. So it varies with respect to the time. So the position of the jet along the jet direction, you can see along the jet direction the injection point moves. Okay, so that the paint will be distributed uniformly. So that is the reason why I have activated, or I have given that velocity with respect to time, how it is being varied. Okay, maybe I'll select this as an origin only. So it starts from origin. It's not an issue. I'll just save it. Now I'll go to user defined functions, go to that particular function or go to that particular file where it is, and I'll load it. Need to check where it is. View spray painting. So I'll go to that location, spray painting, and I'll load that file, build it. And load it. Then I'll go to the injection 0 and I'll try to initialize with that UDF. So the particles will start injection from that point 00 and 0.005 into current time. So current time is the time of the simulation it is running. Okay. Now I'll try to initialize. Then I'll go to particle tracks and I'll select these, and I'll go to sphere attributes, making this a scale of 12, so that even though it is a particle, for the visibility I'm just made it as a sphere and given as the with 12 as the scale, so that you can clearly see. Right, now after that you just need to go to scene, and I'll try to create a mesh of this wall along with save display, close, and I'll just increase the transparency, and I also activate the particle tracks, save display. So you can see, so this is the point at which the particle starts injecting, or the spray starts injecting. I'll try to record the animation for every 5 time steps. So this is the scene where I want to record the for every 5 time step, and I'm asking it to use active. So this is the view which will be activated for the scene animation storage. So then I'll go to run calculation, and I'll change my time steps as 0.001, and I'll increase the time step, number of time steps. So now I'll run calculate. Maybe I'll just showcase you few time steps, how exactly it looks like. Then I'll pause the video, I'll run for few other time steps and show how the video looks like when we save many animations at a time. Okay, so now you can see 20 particle parcels are injected, because there are 20 streams what we are injecting with respect to the cone. That's the reason why we have got 20 particle parcels, and we can visualize that on the screen for every 5 time steps. But I'll run for 2 time steps, and I'll just click on save display so that you can see, and after that you can continue for many number of time steps you want. So now another 20 particle parcels are injected, and in which 3 particle parcels have been coalesced or combined depending on the stochastic collision on the probability basis. So let another time step also run so that I can show you something on the screen, how the particle parcels will be injected. Now so another 20, and again 7 particle parcels have been coalesced. Let it. Okay, then maybe another 40 iterations. So we'll leave for another 40 iterations and we'll check. So because for every 5 time steps will be saved .hsf file. So after this, automatically an animation will be, or an HSF will be created and it will be displayed on the screen. So now you can see the scene. Maybe I'll just stop here. I'll just click save display so that it will be visible. Somehow I'm not, oh sorry, I haven't saved the solution animation, that's the reason. Okay, we select this for every 5 time steps and preview it. This is not the direction what we want. This direction is active, click OK. Maybe if you want to see the particle tracks, click here, track, and with respect to particle diameter we will check particle diameter, track, save display. So you can see here particles. Okay, so maybe I'll just click on the animation view also, whether we are able to see it or not. Shall we run for another 5 more time steps? So I just want to show it with respect to this sphere or hemisphere of wall and as well as the particles combinedly. Just pause for now. So now you can see it is visible. The particles are being injected. Starting. Of course, I have not stopped the simulation. It's running. So now these particles go and hit onto this particular surface, and the wall film will start forming also. Okay, I'll just leave it, and after some time I'll just show you the animation. Okay. Now, so this is the animation what I've extracted. I'll just play it for you. So now we can see the particles are just injecting and there's collapsed, some are breakup forming, and there is a wall film that is being formed. So please do like the video, subscribe, and try to share it among your friends. Thank you.